All right, so our second unit, starting with Chapter 8, is looking at collecting data. Okay? We just spent an entire unit analyzing, both graphically, numerically, analyzing what our set of data looks like. Now, to get to that stage, we need to make sure that our data is accurate, okay, and accurately representing what's going on in this population. So one of our goals here, differentiate between a sample and the population. We'll be looking at different sampling methods today. Okay, when we say that we're taking a sample, that's easier said than done. Okay, most of our work in a statistical analysis is done in the sampling. Okay, so we'll talk about what that looks like. This is just kind of like a summarized, bulleted list of everything. So if you are going back and using these notes to help you prepare for a quiz or a test, okay, trying to remember, is this in Chapter 8, is this in Chapter 9? Use this to help you. Okay? I'm not going to say, we're going to talk about this, we're going to talk about this, we're going to talk about this. But this is more like an after-the-fact kind of thing, okay, to help you identify what we're looking at in these sections. One thing to consider, okay, watch out for these points. A sound statistical design is necessary if we were to trust the data from a sample for drawing sound conclusions about the population. All of that stuff that we talked about in our first unit is worthless if we are working with bad data. Okay? The accuracy of our data is critical for the conclusions that we want to draw. In sampling from large human populations, however, practical problems can overwhelm even sound designs. Okay, we can have everything in mind as to what we're going to do and how we're going to execute our survey. Okay, but sometimes just the sheer volume or capacity of what we're trying to measure makes it extremely difficult. And the impact of technology, particularly cell phones and the internet, is making it harder to produce trustworthy national data by sampling. And this was very evident in the 2016 election. We're talking about like the last 20 years, like the way we live our daily life has totally changed. And some of the sampling methods were antiquated and out of date. You'll look at some things called like random digit dialing that randomly identifies landline telephone numbers and asks them survey questions. Well, back in 1960, okay, I get an evening call on my rotary telephone. It's like, good evening, sir. Would you like to participate in a random survey about the upcoming election? It's like, well, sure, I would enjoy that. Like, people don't do that in this day and age. First off, people don't have landlines. Okay? So, to be able to connect with these individuals, that's the first hurdle. We have a much more diverse population than we did back in 1960. So being able to connect to all groups of people, all representatives, or all likely voters being equally represented, that can be extremely difficult. So we'll expand more on this idea towards the end of our lesson about how technology has impacted what we're talking about. We'll talk a little bit about that 2016 election as well and what went wrong, because all of the polls, all of the surveys going into election night were predicting that Hillary Clinton would win. And we know that that didn't happen. And how has polling changed over the last 4 years to catch up with being more accurate, being more predictable? Because it is difficult. It's extremely difficult, especially on a nationwide scale, to perform an accurate survey. Now, to start out, we need this distinction between a population and a sample. When we say this word population, we're not always referring to the 330 million people in this country as a nationwide population, okay, or a global population. Okay? We can mean whatever group of people we want to mean. We could have the population of students in this high school. Okay? That's a more, that's a number that's easier to work with. But because the population is usually large and difficult to access in terms of asking everybody a question, instead we rely on a sample. Okay? A sample is the part of the population from which we actually collect information. We use information from a sample to draw conclusions about the entire population. Now, the sample should be representative of the population that it is describing. That's one of the big flaws when the sample does not match the population, and that dramatically impacts the results that you obtain. Okay? And the thing is, you don't know that the conclusions that you're making are bad conclusions, at least not immediately. Right? You trust the numbers that are in front of you. But you have to trust the process and follow along with the process to make sure that those numbers are as accurate as possible. Okay, this is statistics in a nutshell right here. Using a sample to say something about a larger population. We know that if we were to survey everybody in the population, that's called a census. It's a word that's been pretty common this year because our Constitution requires that a nationwide census be conducted every 10 years. So our 2020 census started, well, the preparatory action started in late 2019, and it just wrapped up like a couple weeks premature by a court order just within the last week or so. The census is supposed to count every single individual in this country. And that data is used for government purposes, determining representation, determining taxation, determining budgetary needs in terms of allocation of money and resources to different parts of the nation. And we make a lot of our decisions based off of data obtained in the census. And our forefathers had the oversight to implement something like that back in 1789 when the Constitution was ratified. Now, there's an argument that the census is outdated. Every so often you'll hear about some politician who says we should implement a constitutional amendment to get rid of the census. And that seems like a ludicrous headline, okay? This wacky politician, and it doesn't really get very far. We've got a lot of other needs that government is working on at the moment. But it's really not that outlandish if you think about it. We spend billions of dollars on that census. It takes a lot of time, a lot of money, a lot of effort. And there is a strong argument out there that you could get just as good results, just as accurate results, if not more accurate results, with a well-done random sample. And part of what I want you to think about over the next couple days is that maybe there is something to that. If you put that time, that money, those resources into performing a well-executed random survey, and you expand that to represent the population as a whole, you can get just as good information as the census. And the census is often flawed in terms of how many people are there, and where those people are located. Census is not a snapshot. I said it started beginning of the year and just wrapped up. If we're saying 330 people live in this country, people are constantly being born. People are constantly dying. People are constantly moving. Things change. It's impossible to count all 330 million people right now. There's my census. It can't be done. But that's what we want to think of it. And there is some legitimacy to that argument that we could get just as accurate information, if not more accurate, if we did a random sample. Okay? It would require a constitutional amendment, though. This sampling design describes exactly how to choose a sample from that population. And the first step to planning a sample survey is to say exactly what population we want to describe. The second step is to say exactly what we want to measure, that is, give an exact definition of our variables. And this is where we start to get back into what we were talking about in our last unit. Okay. Talking about the variables that are being measured. Are they quantitative? Are they categorical? Are we measuring exactly what we say we are? Now, how to sample badly. A sample selected by taking the members of the population that are easiest to reach is called a convenience sample. Convenience sample is a bad way of sampling. Bias can seep into a convenience sample. It can seep into any sample. Let's say that we were interested in surveying within our student body. And because it's convenient for us, we have class mods 5-6. Let's pretend this is normal circumstances. Class mods 5-6. So we head down. You've probably been accosted by my students in previous years. People asking you sample questions about, like, do you do this? Do you do that? How do you feel about this? How do you feel about that? You're just trying to work in the library. You're just trying to eat in the cafeteria. And I got these 12th grade statistics students asking you questions. Well, if we were to head down mods 5-6 and start asking these sorts of questions in the cafeteria or the library, that's a convenience sample. These are the students that are available to us at this time that we can ask these questions. But there's possible bias there. How could that be biased? Any ideas? Without being like, not stereotyping or anything here, okay? But what kind of students are working in the, or down in the cafeteria right now? I shouldn't have said stereotyping because that's not anywhere where I'm going with this. But who's free mods 5-6? Probably seniors, juniors, maybe sophomores. Probably not freshmen, right? And freshmen, you know that you have a very full schedule. So if my data is based off of surveying mods 5-6 down in these common spaces, you're biased against underclassmen, okay? Because they're less likely to be present in those spaces at that time. And it's not something that you're deliberately doing or intentionally doing, but a bias systematically favors certain outcomes. Now, this bias that we're talking about here is a little different than what I mentioned yesterday in terms of a biased question. Okay? It's still the same definition of bias. Okay? It's a slant towards a certain outcome. But our question itself isn't necessarily biased in this case. There's a caution. People who take the trouble to respond to an open invitation are usually not representative of any clearly defined population. Okay? People who just answer some question because it's right there, well, that's not representative of a bigger population of interest. Okay? That's leading to a voluntary response sample. Okay? Convenience sample, Sometimes we'll go with it, recognizing that it may not be that accurate. A voluntary response sample is worthless. Okay? It's a type of convenience sample, but a voluntary response. And don't confuse this in terms of like, I volunteer to participate. Okay, that's not what we mean by voluntary response. Voluntary response is like a little quick poll. Like if you were to go to the Post-Gazette's website, okay, they always have some little poll, little survey questions on the right side. Okay? That's a voluntary response sample. Okay? There are people who just, that question interests me, I'm going to answer it. And then they give the results. Well, these are the results of the people who chose to answer those questions. It's a voluntary response. It's not representative of any population. Okay? People who choose themselves by responding to a general appeal. Voluntary response samples show bias because people with strong opinions are most likely to respond. Let me give you an example here. Now, this is a bit of an outdated example, but it helps drive home the point even more. In its March 1995 issue, USA Weekend magazine asked readers to return a survey with a variety of questions about sex and violence on television. Of 65,000 readers who responded, that's actually a pretty good number, right? 65,000. 97% of them were very or somewhat concerned about violence on TV. Based on this survey, can you conclude that about 97% of U.S. citizens are concerned about violence on TV? No, you cannot. This is clearly a voluntary response sample. First off, this magazine, USA Weekend magazine, I have no idea what it is. I think it's affiliated with USA Today, but I don't know. They're probably bankrupt right now because magazines don't really exist in 2020. But this was 1995. The way they did this survey is they asked their own readers, their own subscribers, to return a survey answering a variety of questions about sex and violence on TV. They have to return this. This is 1995. The internet is barely in existence. It's nothing like what we see today. So returning a survey means filling this out, putting a stamp on it, putting it in a mailbox, and it eventually gets there. It is not just like a quick online survey like we're used to. Is it that surprising that 97% of the people who responded are somewhat or very concerned about the violence on TV? No. Because who are these people who are responding? They are the people who are very concerned about the violence on TV. They want their opinion to be known. If I answer this question no, like, no, there's not too much violence on TV, or, maybe there is, but I don't really care. You're not going to go out of your way to fill this out, put a stamp on it, mail it back so that your opinion of, I don't really care if there's violence on TV or not, so that that opinion can be heard? No, it's those with strong opinions. They are the ones who are likely to respond. That's why you see things in this polarized world, and we listen to the news that we want to hear. They also do their own voluntary response surveys. And is it that surprising that the results are very dramatic? A Twitter poll, that's a voluntary response survey. Okay? I don't care about the opinions of the people who follow you and if they choose to participate in this poll. No, they're fun, quick polls. That's all they are. You can't draw any results or any conclusions from them. When you hear about a survey or a study that's done scientifically, that's when you know that you're using these randomized sampling techniques to perform a good survey. Be aware of those convenient samples and the voluntary response samples. So, random sampling, this is the method for obtaining representative information. Now, this word random, we have a loose idea of what it means, but in a statistical sense, random means everyone has an equally likely chance of being selected. Everyone in the population everyone in that population of interest has an equally likely chance of being selected. So it's this principle of being randomized that allows us to draw accurate conclusions. Okay? Now, a simple random sample, we see this a lot. Simple random sample, it's abbreviated SRS, of size n consists of n individuals from the population chosen in such a way that every set of n individuals has an equal chance to be the sample actually selected. We see that definition of random in this definition of a simple random sample. Now, we see that word simple, it's kind of like a misnomer. Okay? It's simple in that it's easy to understand what it is. It is not simple in execution, especially across a large population. Okay? Now, in practice, to identify or implement this randomness, people use random number generators either on the computer or the calculator. I'll show you that. I love this sentence here because it's like, if you don't have technology handy, you can use a table of random digits. All right, when would you not have technology available to you, but you do have a table of random digits? Like, you know how Mr. Laboda carries like his pocket constitution in his like front pocket, his front shirt pocket? Like, is it my obligation as a stats teacher to carry like a table of random numbers with me at all times or something? I mean, that's kind of what this is implying. I'll show you what that looks like. I'll show you how you can use it. But let's be honest. We're going to use computer or calculator to randomize things for us. Okay. To choose a simple random sample. Okay? Let's talk calculator first. Let me bring up my calculator screen here. Take over. So let's say that we are interested in getting a simple random sample from the 1,400 or so students in this school. Okay? So our student body population will be our population of interest. To do a simple random sample, you need a list of everybody in that population. That is what's difficult about a simple random sample. Okay? Sometimes that list is practical. Right? In our school environment, yeah, we could generate a list of every student in this school. If I were to do a nationwide simple random sample, we don't really have that, or at least we don't have access to that as everyday citizens, a list of all 330 million people in this country. But across the 4 grades in this high school, yeah, we could probably get that, or at the very least, like, use a yearbook or something to help us serve as that list. That list is called a sampling frame. Okay? You need a sampling frame in order to do a simple random sample. Now, with the calculator, if you were to press this math button right here on the left and over to probability, in this probability menu, we have a few random generated functions here. The first one gives you just a random decimal between 0 and 1. Okay? We don't really need that. Instead, we're going to choose option number 5, which is a random integer. Now, for our case here, we want a random number between 1 and 1400. Okay? Everybody in our population is going to have a number. So we can start with the freshman, person 1, 2, 3, 4, all the way up through, John, you're going to be person 1400, senior, okay? If you're in our sample, then, I don't know, that's special for you today. So, let's say we want a sample of size 30. We want to select 30 individuals from this population of 1400. So we give it these constraints, go down, paste it in. Person 41, you're in our sample. Person 1173, you're in our sample. 866, 288, 1379, and so forth. We can scroll across and get all of these individuals, okay, match it with our sampling frame of who is in our sample. Now, that's who should be in our sample. Another part about what's difficult with a simple random sample is that now that I've identified person number 423 as being in the sample, it's my ethical responsibility to hunt that person down and see if they want to participate. If they do not want to participate, that's okay. I'd randomly select another individual to replace them and get my sample size to 30. But if it's hard for me to get person 423, okay, or if I go knock on 423's door and 423 is not home, I can't just go to 424 next door and say, you've been selected to be in my sample, because they haven't been. Okay? There's possible bias that could seep into that. Okay? If you're not going with the individuals that are selected in your sample, you're making it more convenient for you, and that's seeping into a convenience sample. Okay? And there's possible bias that could go with that. It might not seem like as big a deal, but there are problems that you need to take into consideration. Simple random sample is very difficult to execute properly. Okay? We'll look at some other methods that might be a little bit more practical than a simple random sample. Now, I had mentioned that table of random numbers on our Canvas homepage. Down at the bottom, I've added a couple things. One of them is a document that includes the z-score table, but it also includes a bunch of other statistical tables. One of them is this table of random numbers. Okay? And that's as exciting as it sounds. It is a big page filled with just random digits, 0 through 9. Now, the way this works is you are identifying some place to start. We still have our population numbered 1 through whatever, 1400. But when I have those restrictions, okay, I'm working my way through this field of numbers to identify something that would fit under 1400. Now, for that to happen, my first digit needs to be 0 or 1. Right? So I'm looking for 4-digit numbers. So let's say I want to start in row 106 here. I'm going to find my first number here that's 0 or 1. There it is, number 1 right there. So person 1735, but 1735 is not less than 1400, so that's meaningless to me. So I continue on. There's a 0 right there. So person 0131, person 131 is now in my sample. Okay? Continue on to the next 1 or 0 that I find. Going across, here's a 0. Person 895 is now in my sample. Okay? Obviously, it's a little bit more tedious than using technology that just spits everything out at once. Okay? But that's how you would use a table of random digits. Not something that you really want to do. There's an example problem here from the book that I think the background of the problem is that they are going on spring break to a certain town and they want to select from a random sample of possible hotels for them to stay at. So they list every available hotel and assign them a number 1 through 28. And the group of students in this spring break party, they want to choose from 4 possible hotels. So they randomly select these 4 hotels, and to do this, being the statistics students that they are, they use a table of random digits, and you can see how they kind of identify here. In this first number, we see 0, 5, so there's our first element in our sample, Beach Castle. Continue on, there's 1 and 6, so 16, the Radisson, that's in our sample. Continue on, there's 1 and 7, 17, the Ramada, that's in our sample. We continue on, 40's too big, and then we get what? C Club, 29 or 20. That's the last one in our sample. Okay. And from there, they could make their decision about what hotels they're staying at. This was feasible in a population of 28 individuals. It was somewhat feasible in our school population of 1,400 people. We get much bigger than that, though. It's next to impossible to get that sampling frame. Again, the sampling frame is a list of everyone in the population, and that is essential to do a simple random sample. And you can't give everybody a number if you don't know who everybody is. And that's what you need to do a simple random sample. Now, with this, once we have our sample, the purpose is to infer things about what's happening in our sample as to that's happening in our population as well. And the purpose is to give us information about a larger population. The process of drawing conclusions about the population on the basis of a sample of data is called inference. Okay, statistical inference is like one of the big ideas of what we're going for. Why should we rely on random sampling? Okay? This kind of comes down to that same question about should we still hold our nationwide census every 10 years? Well, it helps us eliminate bias in selecting samples from the list of available individuals. Again, bias is not just in the wording of questions. Bias is in who is contacted and who is participating in this sample. Okay? We said it was convenient to us to go down to the cafeteria mods 5, 6 and conduct our surveying then and there. But that had bias against underclassmen who are less likely to be free and in the cafeteria at that time. The laws of probability allow trustworthy inference about the population. We'll be getting into a probability unit. I know we just started this unit, but that's our next unit, is probability. That's the most math that we'll be doing this year in that probability unit. A lot of complex math. We put a lot of faith in probability, and for good reason. And we can trust the randomization to give us the likelihood of something actually happening. Okay, if something is truly random, if a fluke happens or an error happens, we can usually quantify the likelihood of that occurrence. That's what probability does for us. A probability is the biggest tool we have to being able to quantify what's going on. Results from random samples come with a margin of error that sets bounds on the size of the likely error. With all of these election polls and election surveys that are going on, you're presented with a margin of error. And I think the last I heard, and it depends on who's doing the survey and who you can trust, but I think in Pennsylvania, it was something like 53% of those surveyed were voting for Joe Biden in Pennsylvania. Now with that, there's a margin of error of plus or minus about 3%. The margin of error is just as important as this number right here. This number is saying that 53% of our sample said that they are voting for Joe Biden. We are hoping that that is representative of what's happening in the entire population in terms of accuracy. But the margin of error gives you a boundary. It could really be 3 less than that, so 50%. It could really be 3 more than that, 56%. And this is the certainty that we have, that we are fairly certain between 50 and 56% of our population is voting for Joe Biden. Okay? That's what that sample survey does. That's what that poll does. Now on the flip side of this, that doesn't automatically mean that 47% say they're voting for Donald Trump. You have non-voters, you have third-party voters, you have other things that can impact those results. But what you're looking for in terms of saying if you can definitively say that the population is favoring one candidate or another is if those margins of error do not overlap. Okay, let's say that the Donald Trump proportion here was, change my colors for political purposes, right? Let's say that that proportion was 46%. Also, with a 3% margin of error. Okay, we'll look at where margin of error comes from in just a moment. That would put this boundary, 46 minus 3 to 43%, 46 plus 3 to 49%. This would mean that there's no overlap between those two boundaries. It could really, from our estimates, be as high as 49%. This one could be as low as 50%. If there's no overlap between those boundaries, then you're pretty sure that there's a difference between those two. Okay, in that population. We can't just go with the individual numbers because this is what's happening in the sample. Who cares about the sample? We care about the population. It's not just those 2,000 people who are in our sample that are voting. It's all of the people who are likely to vote. That's usually the first question that they'll ask in one of these surveys. How likely are you to vote on election day or vote in all these other formats that we have? Okay? Because they want their population of interest to be likely voters. Okay, are you registered to vote? How likely are you to vote? Those are the questions they want to know before they start to get into who you vote for. Margin of error is based off of that normal curve. Okay? We'll look at that more closely in the second semester when we get into statistical inference. But a rough equation for margin of error is 1 over the square root of n. Okay? N is the sample size. So let's say that we had a sample size of 1,600 people. It's a pretty good sample. So follow this equation. Square root of 1,600 is 40. And 1 divided by 40 is 0.025. We interpret that decimal as a percent. 2.5% margin of error. from a 1,600 sample size. You can clearly see from this inverted relationship why the bigger the sample size, the better. The bigger the sample size, the more accurate you are with your inference about the population. Let's say that I were to make this even bigger than 1,600. Let's say I were to make it 10,000. Square root of 10,000 is 100. I should know that. Just typing things in. 1 over 100 is 0.01. That would give you a 1% margin of error. Well, yeah, a 1% margin of error is better than a 2.5% margin of error in terms of accuracy. But now I have 10,000 people in my sample. 10,000 people that I accurately reached out to in a randomized manner. That's difficult. If I were to go with a much smaller sample size, let's say I only had 100 people in my sample. Square root of 100 is 10. 1 over 10 is 0.1. That's a 10% margin of error. That's really big. And so again, if I did my own survey of 100 people and I got the 53% across 100 people, now I'm pretty sure that that actual percentage is between 43% and 63%. That's not really helpful. Again, who cares about what the sample said? You want to know about how accurately that sample predicts what's happening in the population. Any questions with this? There's our one equation for the day, for the unit. Okay. Margin of error, 1 over the square root of n. Now, we already mentioned a couple of reasons as to why a sample is better than a full-blown census. Okay? It's faster to collect. You can devote important resources, money, time, energy, to the most accurate information possible rather than just the sheer volume of responses. That's what you're looking for in the census. There's also this one. When measurements destroy the units being tested, a census is not feasible. Now, obviously that doesn't make sense if you're talking about like surveying people, all right? But I go to the doctor's office, I have a blood sample taken. That sample is representative of all the blood in my body, and they do their tests on that sample, and hopefully that sample is indicative of what's really happening throughout my body. Now, when they're done with that blood sample, they don't pump it back into me, they get rid of it. Okay, so even things like that are using these sampling methods. Now, I've talked about some of the flaws and limitations of that simple random sample. It's requiring that sampling frame, that list of everybody in the population. And that's the biggest drawback to a simple random sample, is that that list is sometimes not practical. So, if we have this large population we're trying to describe, one method that's used instead of a simple random sample is called a stratified random sample, and it still has the letters SRS, so that's a little bit confusing. But a stratified sample involves breaking the population into groups called strata. And then from those groups, you're taking a simple random sample within each of those strata. Now, oftentimes this is done multiple times. Let's say we're using that nationwide population as our overall population of interest. Maybe I stratify by region of the country: Northeast, Mid-Atlantic, Southeast, Midwest, Pacific Northwest, all that stuff. And then I stratify again by state, and stratify again by county, and by municipality or township. It's something where you get to a scale where it's more reasonable to obtain that sampling frame and perform the simple random sample. Again, if I'm going from 330 million people and I identify person number 146,733,292, I then have to hunt down that person in Tucson, Arizona, and get them to participate in my sample. And if they don't want to participate, again, it's not that easy. I can't just go next door and say, yeah, it was you that I selected to be in my sample. No. You want to stratify down to a level that's more manageable to then conduct that simple random sample. Okay? So you could have a multi-stage sample that's just purely made up of stratification after stratification. Or you could also invoke some of these other techniques and multi-stage sample in different ways. Okay? Couple others that are important for us. Okay, these are the big ones that we want to consider: stratified, cluster, and systematic sampling. Yeah, we'll talk about those. Random digit dialing is on its way out. It has significant drawbacs in terms of responsiveness. People aren't likely to participate. They're biased towards landlines and elderly people, because elderly people have landlines. Right? And it has a lot of flaws. We talked about the election in 2016. That was one of the issues with the surveying and the sampling going into that election. Okay? But these methods right here are the big ones that are considered good sampling methods. With stratified, we said you're dividing the groups into strata. It has its advantages. In addition to getting those individual estimates, you also have estimates about all of the strata too. So if I stratified by state, I also now have a representation of the opinions of people in the state, as opposed to just nationwide. I have the region, the state, the county, the township. Okay? I've stratified on all those levels. So maybe those are of value to me. Okay? Cluster sampling is similar to stratified in that you're still splitting it into groups. Obviously, this one you call clusters rather than strata. But the key difference here, the big perk of cluster sampling, is you do not need a sampling frame. Do not need a list of everybody in that population. That's what's good about cluster. The way cluster sampling works is you split the population into these groups based off of some insignificant feature. Okay? We said with the stratified, they had some identifying characteristic. Okay? Usually that's a geographic thing. I give you an example here of students on a college campus that you're interested in students living in a dorm. So at this big school, they have 30 dorms. Each dorm has 6 floors. So, some quick math there, 30 times 6, you have 180 floors. Those are your clusters. So, what you're doing with cluster sampling is you take a simple random sample of clusters, not of individuals. So in my random number generator, I do 1 through 180, floor number 72, floor number 134, floor number 18, however many I need for my sample size to be sufficient. Okay? Those floors are in my sample, and then I go interview everyone on those selected floors. That's cluster sampling. Okay? It does not require a list of everybody in the population, because you're randomizing and you're taking a random sample of the clusters and then measuring everyone within those selected clusters. Okay? So again, these are two similar methods. You're splitting them into groups. Stratified sampling, okay? You stratify by region, by group, and then eventually take a simple random sample within that smaller group. Cluster sampling, everybody split into their groups, and you're taking a random sample of groups of clusters. Questions about the differences between those two? Yeah.
For the cluster, since you don't have to list each individual, you still have to list like this is what's going on, this is what's going on.
Yeah, but that's a little bit easier because, like, I don't know, we have probably several thousand students across these 180 floors, but you don't need a list of every student there. Okay? We could just do a cluster of those. We have those 180 floors, so 1 through 180 identify what those clusters are. Now, I'm not saying that cluster sampling would always be practical. Okay? If we're talking about that nationwide population, and we're looking at clusters nationwide, that everybody has some kind of like unimportant identifying characteristic, that probably doesn't make sense on that scale. You might want to stratify a few times first. Get it down to like the township or the municipality level, and then maybe you cluster sample based off of neighborhoods within that community and take clusters of neighborhoods, okay, and identify and interview everyone within those selected clusters there. Okay, that might be a more practical step as part of a multi-stage sample. Last one for systematic sample. Okay, students tend to like this one. Systematic sample, you're following a system. You're following a process for identifying who's in your sample. Okay, now, you do need a frame for this. You do need everyone in the population, like either in front of you or a list of them. Okay, so you need sampling frame. But you're dividing that population list and then following a process for your selection. Let me give you an example of this. Let's say, I know it's kind of outdated, but like you have a phone book and you have everybody in the community in this phone book. That's serving as your sampling frame. You randomly pick some place to start in this list and then put your finger on it, and this individual, that's the first one in my sample. And then I'm going to follow a process. Maybe I count down like 10 names. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the next person in my sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's the next person. Next person. Next person. Every 10 people in that list are in your sample. That's a systematic sample. That can be beneficial to you if you have like the entire class in front of you and you wanted a systematic sample. And every third person, 1, 2, 3, 1, 2, 3, 1, 2, 3. That's a systematic sample for getting your sample. Now, depending on how you execute your system, there could be possible bias there. Like I mentioned, a phone book or something, some directory. Those are usually alphabetized, and if your step size is not large enough to get you adequately through the population, then you might like never get out of the A's or be stuck in the beginning of the alphabet, and maybe that is bias that's relevant to your survey, maybe it's not, okay? But it's a source of possible bias that you should consider. Okay? So systematic, it's somewhat easy in its execution, okay? But it's not flawless in certain cases, and you need to be aware of that. Okay, so here are our good sampling methods here. Simple random sample, stratified, cluster, systematic, multi-stage is some combination of these. We also have bad methods, convenience, and voluntary response. Okay? You'll see questions that those are sampling methods. They are techniques. They're not good ones, though. Okay? They have inherent bias built into them. Questions right now? Okay. Last couple things here. Cautions about sample surveys. Good sampling techniques include the art of reducing all sources of error. Undercoverage. That was one of the problems in the leading up to the 2016 election in terms of the polls not predicting what happened in the election itself. Okay? Undercoverage occurs when some groups in the population are left out of the process of choosing the sample. Okay, so the pollsters were using outdated and antiquated techniques for obtaining their survey data. And it wasn't reaching a lot of rural voters, okay, because they had all this technology that was available to them for the first time in a mass scale. And the way they were implementing it wasn't representative of all likely voters. Yeah? And they didn't get to a number of communities that didn't have the technology that was more common in urban or suburban regions. Right? And that led to undercoverage in their surveys, in their polls. Non-response is also a big problem we see in today's survey. Non-response occurs when an individual chosen for the sample can't be contacted or refuses to participate. Okay, I said that person who I identified in, Tucson, Arizona, that person was selected to be in my sample. If that person doesn't pick up or refuses to participate, that's a problem. That's time, that's money, that's an exhaustion of resources spent trying to pursue that person that maybe gets replaced in the sample or maybe doesn't. Maybe that sample size is smaller. Okay? Or I'm starting to get people who just are the ones who want to participate, and then it becomes more of a voluntary response sample. Okay? That's a problem. A systematic pattern of incorrect responses in a sample survey leads to a response bias. Okay? Maybe the line of questioning makes one group of people more likely or more willing to participate than another group. That's a problem. Okay? Some of that maybe goes with the wording of the questions, which is what we talked a little bit about yesterday, and that's what I'll pick up with on Monday when I next see you guys. Okay? The wording of the questions is the most important influence on the answers given to a sample survey. Right? Any questions here? All right. So, close this out. All right, so I will see you guys Monday. We'll pick up talking about the wording of the questions a little bit more and finish up talking about our sampling. All right, have a good weekend. I'll see you.